And what are isotopes? Isotopes. And what are isotopes? Isotopes are the elements having same atomic number but different atomic mass. Okay, so and you still don't know about the atomic mass, atomic number. So we will discuss it one, but because we are just studying this one, so we have to note it down in the copy that isotopes are the elements that are having that are of same means atom of same element like carbon 12 and carbon 14. So this is the atomic number. This is 6 both are having same, but the mass is different. That is written this one. This is the mass. So this is also of carbon atom. This is also of carbon atom. Both are carbon atom, but have different masses. Note it down. Noted, everybody? Done? Noted, everybody?
Yes, sir.
Rumaisa, Avni. Avni, you have not done the physics portions. I have checked your copy. For the third test. And Rumaisa, you also? You have not done each and every question. The second drawback was that he said that atoms of different element have different mass. Okay, this statement does not hold true. This statement does not hold true. In case of which type of in case of isobar. Isobars are the atoms having of different elements but having same masses. For example, argon has 40 mass and it is going to have atomic number this one argon, and calcium is going to have 40 mass. Both are going to have mass. This is the symbol calcium, Ca is the symbol, Ar is the symbol. This is the atomic number. 18 and 20 is the atomic number of argon is 18 atomic number, and calcium is going to have atomic number 20. But the mass of argon and calcium is same, that is 40. So these are the isobars, different atom but same masses. Okay, so different, we can say that atoms with different atomic number but same mass are called isobar. It does not hold true in case of isobar. You can write it. So in case, for example, in both argon and calcium have same masses, have same mass, that is 40. Okay, so please note it down, everybody. Noted, everyone?
Sir, noting 1 minute. Yes, sir, done.
Other students? Abdul Jabbar, Avni, Riaz,
Sir,
Ashita.
done.
Okay. So let's move further. Now moving to the next part, the other drawbacks, there were also other drawbacks, but in case of this is if the statement is this one, atoms can't be atoms are indivisible, okay, which can't be created or destroyed. If if the statement is only up to this, so we can say that this postulate is incorrect because we can destroy the atom in the nuclear reaction. But if it is written chemical reaction, so we cannot destroy the atoms in the chemical reactions. Okay, and these are the two postulates that you have written in the previous class. Okay, those students who are have not done this one, will let you take the screenshot of this one. Okay, and you have to write this one in the copy. These are the Dalton postulates that Dalton said that atoms can neither be created nor destroyed in a chemical reaction. So this statement also prove the law of conservation of mass, and atoms combine in a small ratio of whole numbers to form compound. This also prove the relative numbers and kinds of atoms are constant in a given compound. Okay, so this one is also, we can consider this one as, okay, so you can write this one. This is the law that proves the law of constant proportion. So in the examination, if the question is being asked that which law hold true for this, which postulate of dynamic theory prove the law of constant proportion, so you can write the answer here. Okay, understood? This postulate prove the law of constant proportion, and this postulate prove the law of conservation of mass. Okay, these two are very important, and others are also important because like this one, atoms of different element have different masses. So this statement up to here is incorrect, but and chemical properties is they will have the same chemical property. So don't write the other statement, the other part. If I'm talking about that they are a different atoms, so they must have different chemical properties. So this one is true, they have different chemical properties. Atoms of same elements have same chemical properties, identical chemical properties. This is true. But this statement of mass that have identical mass, they can have different masses. For example, in case, if I'm explaining here this one, that both carbon and carbon 12 and carbon 14 have both same chemical properties. So if Dalton is saying that atoms of same elements have same masses and same chemical properties, so same chemical property is the correct one. But if he's saying same masses, so it may be incorrect. Because as you know that carbon can have atoms of two types, that is of mass 12 and mass 14. So same element but different mass, okay? But still they have the same chemical property. This one and this one both have the same chemical property. And in the next statement, he said that atoms of different elements have different masses and different chemical properties. So different chemical properties is correct. This argon and calcium must have different chemical properties. But if I'm talking about this one, that they have different masses, they can have at different elements can have same masses. It is possible. Okay. Okay. Understood? Understood, yes, friend?
Yes, sir.
Nobody's. Yes. Okay. So dear student, these are the symbols of some elements which are important. So please make a table of this one, items of different element with their symbols. So please, these are the important one. Please note it down. This is very important that going to be coming in your examination. So please note it down. Aluminium, make this table. If you know the formula of some of them, then don't write that one. Only those in which you are not confirmed and you may forgot sometimes. Sometimes you forgot, sometimes you remember, then note that one only. And the formula or the symbols of the element that you know 100%, for example, hydrogen, you know H. Don't write it, hydrogen. Okay. Those you don't know and those in which you are not 100% sure, only write those. Done?
No, sir.
Last. Rashida, are you there? Rashida,
Yes, sir.
are you writing?
Yes, sir.
Done?
Yes, sir. Done.
Everybody in the class done?
Yes, sir.
Okay. Okay, so let's move further. The other next topic is atomic mass. Let me explain you that what is atomic mass, okay, and what is atomic mass unit. Okay, atomic mass is the mass of an atom, of an atom. So you know you are very much familiar that atom is very small, very tiny. Even we can say that it is very small in size. Okay, so depending on the type that if we need to measure the mass of an atom, we need we need something to compare it. That's why atomic mass is also called relative atomic mass. Atomic mass is also called relative relative atomic mass. Atomic mass, because we are just comparing. This is the comparable mass. For example, if you need to measure a distance from one point to another point, that you are measuring the distance from one point to another point, so A to B, what you will do, you will start comparing. You have a certain amount, certain measurement skills, like you have 1 meter scale. And if you move from one A to B and you get this distance, the multiple of this one as a multiple of 10. Means this 10 times you can get here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, if you get 8, then it is 8. Okay. 8 meter. If you get 10 times, then you get 10 meter. If you get 100 times, you will get 100 meter. So this is the measurement, means you have taken this. For example, similarly, if you need to measure instead of a distance, if you are measuring the velocity, if you are covering 60 kilometer in an hour, you will say that the speed is 60 kilometer per hour. So here we can say that we always compare the mass. We are just measuring the compare. We have just some standard unit, and we are just comparing that one. Okay, we are just comparing that one. You understood? Hmm? So if you are measuring a mass, for example, if you went to buy some fruits, okay, you went to buy some fruits, then there is a scale here, okay, and this is scale, or there is a balance. We can say that this is a balance. Here is a balance, and this is scale. Here you put some weight on this one, okay, and this is a scale here, okay, okay, and you just put some kg, push weight here, the 2 kg, 3 kg, okay, and then you start putting your fruits or anything. You just start comparing this one, because you have just measured that. You have some standard unit when you went to the if you went the Royal Society, okay, uh, in France, I think it is in France. We have 1 kg standard unit weight, okay, 1 kg is standard unit weight, and then other quantities, the other countries, sorry, go there and just compare that weight and just make the multiple of that one. Okay, so 1 kg standard weight is capped, okay, in France. Similarly, 1 meter length is a standard length that has been actually, because in the earlier time there were certain other different quantities. Some start using foot, okay, some start using palm to measure. Palm size cannot be constant for every person, so they start measuring some different. So the countries sit together and just made that this is 1 meter distance, okay, and from today this is 1 meter distance, and this 1 meter distance will be uh, arbitrary. This is arbitrary chosen. This is arbitrary chosen that we have chosen. This length is 1 meter, and we just start comparing that one. Okay. So this is this the distance we measure, the mass we measure. We are just comparing it. If we are having 5 kg something, so it means that this is the 5 times of 1 kg, and this 1 kg we have just made it standard. So, for example, if you are just measuring the mass of an atom, so because atom cannot be measured in weight in like 1 kg, 2 kg in gram, because gram is a very big quantity. Okay, you cannot measure it at the size of atom with grams. Okay, you need to make a relatable quantity that is very small in size, and that can measure the mass of an atom. Okay, so we initially made hydrogen, because hydrogen is very small. So we just make that hydrogen, one atom of hydrogen, one atom of hydrogen is actually from today we will just start comparing the other mass of atoms with this hydrogen atom. So we just kept this side like this way and this way. We just kept the hydrogen atoms here. If, for example, we just put a oxygen atom here, O2, we find that 32 hydrogen atom is equals to one oxygen atoms. Similarly, we just kept uh, the carbon atom here, then we find that that's hydrogen 12 hydrogen atoms is equals to the mass of one carbon atom. Okay, mass of one carbon. So we just start measuring, we just make the hydrogen as a standard unit. But due to some problems that scientists were facing, okay, we just replace the hydrogen, because hydrogen is not easily available, and it is very rare gas, not easily available. Just comparing hydrogen, or just putting everywhere. We are not, this is just, I'm showing you that we are just comparing, but this is not the technique to measure the mass of an atom or compare the mass of an atom. So actually we just choose carbon, not as a carbon, but 1/12 part of a carbon atom. Like this is a carbon atom. Okay, we just choose carbon atom for comparing the mass, but not as a carbon, whole carbon. We just will choose 1/12 part. For example, we have a pizza and we just keep it slices like this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the slices of pizza. Okay, the one slice, two slice. So similarly, if we have 1/12, means if we part this carbon into 12 part, then the one part of this one part of this one will be considered as or we can say that 1/12 part of carbon 12 atom. Why I'm just writing carbon 12? Because there are the two types of carbon atom, carbon 12 and carbon 14. So 1/12 part of carbon 12 atom. Okay, 1/12 part is selected as standard mass. Okay, you understood? 1/12 part of carbon 12 atom is selected as standard mass or comparing mass. We just start comparing. Okay, got it? So if I talk to you that what is the mass of magnesium atom? So we just try it and we just find that one magnesium atom is equal to is equal to 24 into 1/12 part, or we can say 24 times the mass of 1/12. Means if we have an atom of carbon, what is the mass of carbon? We just divide it into 12 parts. Okay, so the one part of that one is considered to be a standard mass unit. So 24 times the mass of 1/12 mass of carbon 12 atom Okay, similarly, if we have carbon, if we have we have the hydrogen, then one hydrogen atom is equals to 1 into 1/12 part of carbon 12 atom. Okay, so we just choose the carbon. First, we choose the carbon because carbon was easily available for comparing the mass of other atoms. Okay, actually, we cannot have the gram because 1 gram is very large or very huge quantity. Okay, 1 gram mass. If we are just start comparing the mass of an atom, we want to compare we want to know the mass of carbon atom. So if we are just measuring the mass of an atom, which is very small, we cannot have. For example, it is just similar to that if you want to measure the mass of an ant GT, okay, with the mass of 50 element. You are having a 50 element in one container, one side of this one. So this is 50 elephant. Okay, and here we are having only one ant. So how can we compare the mass of 50 elephant with one ant? It is irrelevant. We cannot have this one. We should have some mass which is approximately equal to the mass of an ant. Okay, so we can consider another thing that is similar to ant, that is small in size. We cannot compare. So just comparing a mass of an atom with 1 gram, 2 gram, or 1 milligram or 1 milligram, it is just, we are just comparing a mass of an atom with 50 or 1000 elephant. So this is irrelevant. So we just choose an atom, a particular atom. Initially we choose hydrogen, that we shall start comparing. We will just that how much this atom is heavier. For example, if I'm just saying that the mass of one carbon atom is 12 times the mass of hydrogen atoms. So 12 hydrogen atom means 1 carbon atom. So we just choose an atom for its for comparing the mass of other atoms. Okay, so we just choose that one. So initially we choose hydrogen, but due to some problems we We don't choose that one. We replace this one. And finally, we choose carbon. And if we are just, the carbon is not actually smallest size atom. Hydrogen is the smallest size atom. So if I choose a whole carbon atom as one unit, or standard unit for comparing. So then how can we compare the mass of this hydrogen atom? So we say that if we put one carbon atom on this side, then we are having 12 hydrogen atom. If we 12 hydrogen atom. So this will be the mass of one hydrogen atom will be, what is the mass of one hydrogen atom? So one carbon atom is equals to 12 hydrogen atom, mass of 12 hydrogen atom. So what is the mass of one hydrogen atom? So one hydrogen atom will have 1 by 12 the mass of carbon atom. So how can be in decimals? So we just consider this one, that this 1 by 12 is a standard unit now. For now, we just compare this one, that this is a standard unit. For example, let me explain you one more time. I'm just going to explain you. For example, if you have a cold drink price, if you went to the market and you have a okay, and if you have $100 note, okay, or you have that you have 50 real note, okay, 50 real note, okay, 50 real note, and you want to buy a cold drink that is of 2 real only, that is of 2 real. So if I ask you that 50 real notes gives you how many cold drink? It is of 2 real, so you will get 25 cold drink. 25 cold drink. For example, if you have 50 reals, okay, and one cold drink is of 2 reals only, then what you will do? 50 real you will buy 25 cold drink. Then what is the price of one cold drink? One cold drink will be 50 divided by 25, that is of 2 real. And if you went to the market and you said, then the shopkeeper say you have to buy either 25 cold drink, you cannot buy one cold drink. You have to buy 50 cold drink. And how it is possible? You require only one cold drink, and there is a requirement of only one cold drink. And how can you buy 25 cold drink? The shopkeepers then say that, and go to the government and ask him to make a 2 real. We don't have change. And the government make the notes of 2 real. Then you went to the shopkeeper and you can buy. The problem is solved. Here also, if you have one carbon atom, and you are just measuring that one carbon atom is equal to 12, the mass of 12 hydrogen atom. 12 hydrogen atom. So if I ask that what is the mass of one hydrogen atom, because we are just considering the atomic mass. So if I ask you that what is the mass of one hydrogen atom, then you will say that if I have to make this 12 by 12, I have to divide it by 12, then you will get one hydrogen atom. One hydrogen atom. So it must be, I have to also divide this 1 by 12 carbon atom. So 1 by 12 is, if we have 12 part of one carbon atom, if we do the 12 part of an carbon atom, okay, then only this portion, this is the 1/12 part of carbon atom, only this part is going to have the mass that is equal to one hydrogen atom. So instead of making this carbon whole atom as standard unit, we just make 1/12 part. That 1/12 part of carbon atom is standard comparing mass. Comparing mass for calculating the mass of other atom. The whole carbon atom was not considered as a whole. Is not considered as a whole. Okay. For as a standard unit. Okay, we just have 1/12 part of it. For example, in a scale, you have a scale of 15 centimeter. 15 centimeter, 1, 2, 3, you have reading, that is 15 centimeter. Okay, let me explain you one more time. And if you have to measure a length of 5 centimeter only, so will you able to measure with the scale? No. So we just made, if we made 1 centimeter as a standard unit, this 15 centimeter scale is, we can say that 15 centimeter scale, the whole, if we, instead of making this scale as a whole comparable quantity, if we make only a fraction, that is of 1 centimeter as a standard measurable quantity, then you can measure the length of 5 centimeter from this one also. That you can say that 5 centimeter. So if you take this 15 centimeter and you divide it into 15 part, then you can make can measure the distance of okay, of 1 centimeter, 2 centimeter, 3 centimeter. So instead of making this whole as a carbon 12, we just make its 1/12 part as a standard unit for comparing the mass of atom. Everybody in the class understood?
Yes,
Everybody
sir.
understood? So what is the mass? What is atomic mass? So let's you have right. Atomic mass is the mass of an atom. Okay, atomic mass is the mass of an element of an atom. We can consider this one. In 1961, IUPAC accepted the atomic mass unit to express the molecular mass of an element. Noted down, the atomic mass is defined as the quantity of mass equal to 1/12 mass of carbon 12 atom. Or we can write a simple definition that atomic mass tells us that it tells us that how much an atom is heavier than 1/12 mass of carbon 12 atom. Okay, so please note it down, dear students. Note this one. Note this one first, then I'm going to explain it. Note till this, note this point, and note up to here. Okay, note it. Good after class. Romaisa. Done? Noted?
No, sir.
Noted fast. Is RS present today? RS? No. Yes, Ramaisa, why you left the class? Ramaisa, why you left the class? Ramaisa, are you there? Done, noted? Noted, everybody? Should I move forward? Rishita, today you are not responding. Are you preparing for some other exams?
No, yeah, but not really.
That's why I'm just thinking. Okay. So in the previous class, so let's move further. Moving to this one. So later, if we just start comparing this one, so we find that the mass of one magnesium atom was 24 into 1 upon 12 the mass of carbon 12 atom. Okay. Now moving further, if the mass of one sodium atom was 23 times the mass of 1/12 of carbon atom. Okay. Similarly, if we find that the mass of one calcium atom was found to be 40 times the mass of 1/12 of carbon atom. Okay. So instead of writing this mass of 1/12 carbon atom every time, mass of 1/12 carbon atom, so scientists made this one that we just are not going to write every time 1/12 mass of carbon atom every time. So we just give this the measurement of this masses as one atomic mass unit, and in short we write it 1 AMU. The mass of 1/12 means the whole carbon atom is not taken. The 1/12 part of this one, this mass is considered to be as 1 AMU. So we can write that the mass of, instead of writing mass of one magnesium atom is equals to 24 into 1/12 mass of carbon 12. Instead of writing 1/12 mass of carbon atom, this you can write into 1 AMU, or you can write 24 AMU. Similarly, mass of one sodium atom was considered to be as 23 AMU. Mass of one calcium atom is considered to be as 40 AMU. Mass of one nitrogen atom was considered to be as 14 AMU. So this was the that you have written in the table. Okay, so this was the mass of different elements we have calculated. Okay, got it? Got it? But later the science has developed. When the science was developed, we are just able to calculate due to by various techniques, and science was developed. So we were just able to calculate the mass of one carbon atoms in grams. Okay, we were just able to calculate the mass of one carbon atoms in grams, dear students, and it was a huge discovery. So later by spectroscopy method, we were able to calculate the mass of one carbon atom in grams. And grams, this was very huge discovery. So it was found that mass of one carbon atom in grams was 1.99 into 10 raised to the power minus 23 gram. This is very, very small. Okay, 1.9 and 10 to the power minus 23 grams. Okay, and you know, if actually the whole carbon atom was not the mass, or we cannot say that the mass of whole as a whole carbon atom was not considered as standard atomic mass. It was its 1/12 part. So we can calculate this mass also in grams. So we can write that mass of 1/12 carbon atom, that is also equals to 1 atomic mass unit. In grams, it will be equals to mass of 1 carbon atom, that is 199 into 1.9 times power minus 23 divided by 12. So when you divide the whole mass of a carbon atom by 12, you will get its 1/12 part. Okay, so you divide it and you will get the mass. So when you divide it, you will get 1.67 into 10 to the power minus 24, or you can get 0.166. Okay, so we can get 1.67 into 10 to the power minus 24 grams. Okay, you understood? Got it? So this is the mass of 1/12 carbon atom in atomic mass unit. It is 1.66 into 10 to the power minus 24 grams. So this was also written here, that 1 atomic mass unit that we considered as the mass of 1/12 carbon atom is equals to 1.67 10 to the power minus 20. This is in kg. So if it is in grams, you will write it 1.67 into 10 to the power minus 24 grams. Okay. Noted this one?
Yes, sir.
Noted, please. This is 1/12. Okay. Noted. So please note, take a table of this one. The mass of some standard unit, that is hydrogen mass is 1U, carbon mass is 12U. 1U means that is 1 into 1 upon 12th, the mass of carbon 12 atom. Okay, so this is U. So note it down, please. Make this table. This is important. Rumaisa, are you there? Rumaisa? She's
Yes,
not
sir.
responding. Why you left the class previously?
I can't hear you, sir.
I'm saying that why you left the class?
I got disconnected, sir.
Got disconnected. Okay. Are you having exams tomorrow?
Yes, sir. I have my exam tomorrow.
Which one?
English.
English. Okay. Avni, you also? Are you having exam tomorrow?